YB is observing a ship from a lighthouse. Looks like YB needs some help. Let's check out. Is there a way I can find out how far the ship is from the lighthouse? YB is flying a gas balloon and looks at the tree below. Can I find the distance between my balloon and the tree I see below? How do you think such situations can be solved? To solve both these situations, you need to know A. The measure of angle between the observer and the object. B. Vertical height of the point of observation above the ground level. And then apply the appropriate trigonometric ratios to get the unknown length of sides. How do you measure the angle between the object and the observer? Here, the observer is at a higher level above the object as compared to the object. So, we lower our head to look at the point being viewed. Now, to find the angle, let us consider the level at which the observer is standing as horizontal level. We know that the shortest distance between the object and the observer's eye is called the line of sight. In this case, the line of sight is below the horizontal level. The angle so formed by the line of sight with the horizontal is called the angle of depression. It is denoted by angle pi. When the observer views an object which is at a location lower than the observer, then the angle formed between the line of sight and the horizontal level is called the angle of depression. Let us look at the relationship between the angle of elevation and angle of depression. If AB is the horizontal line for angle of depression and CD is the horizontal line for the angle of elevation, then line AB is parallel to line CD and the line of sight BC is a transversal. Recall, when two parallel lines are cut by a transversal, then their alternate interior angles is equal. So, angle ABC is equal to angle BCD. So, angle of depression is equal to angle of elevation. The angles of elevation and depression are alternate angles of two parallel lines cut by a transversal. Hence, we conclude that the angle of elevation and the angle of depression are congruent. YB is standing on a 381 km high cliff on one side of the river and observing the ground on the other side at an angle of depression of 60 degrees. Find the width of the river. Let AB be the height of the cliff and O be the point on the ground at the other side of the river. Then angle OBX is equal to angle AOB since they form a pair of alternate angles. Therefore, in triangle AOB, tan 60 degrees is equal to AB over AO. Substituting the values and simplifying, we get the measure of AO equal to 220 kilometers. So, the width of the river is 220 kilometers. YB is on the top deck of a cruise ship and observes two dolphins following each other directly away from the ship in straight line. YB's position is 154 meters above sea level, and the angles of depression to the two dolphins are 30 degrees and 45 degrees. Find the distance between the two dolphins to the nearest meter. Let us take O as the point of observation. The two dolphins are at point A and B. Since PO is parallel to AM, alternate interior angles are equal. This implies angle POA and angle OAM are equal to 30 degrees, and angle POB and angle OBM are equal to 45 degrees. In triangle OBM, tan 45 degrees is equal to OM over BM. Substituting the values and simplifying, we get the value of BM as equal to 154. In triangle OAM, tan 30 is equal to OM over AM. Substituting the corresponding values and simplifying, we get the measure of AB as equal to approximately 113 meters. So, the distance between the two dolphins is approximately 113 meters. A boy standing at a highest point on a flyover whose height is 40 meters and observes that the angles of depression of two ends of a flyover are 30 degrees and 45 degrees. Find the length of the flyover. Let AB be the height of the flyover where A is a boy line of sight. C and D are the two ends of the flyover whose angles of depression from the horizontal line of vision of 45 degrees and 30 degrees respectively. Angle DAY and angle ADB are 30 degrees, pair of alternate angles. Angle CAX and angle ACB are 45 degrees, pair of alternate angles. Considering the triangle ADB and triangle BAC and substituting the corresponding values, we get BD is 69.28 meters and BC is 40 meters. So, the length of the flyover which a boy is standing is sum of BC and BD, which is equal to 109.28. A straight highway leads to the foot of a tower. A man standing on the top of the tower observes a car at an angle of depression of 30 degrees, which is approaching the foot of the tower with an uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the further time taken by the car to reach the foot of the tower. Let us represent the problem in the figure as shown. Let P represent the foot of the tower PQ of height h meters. Angle of depression from a point A is 30 degrees and at point B is 60 degrees. Assuming the car is traveling at a uniform speed of v meter per second, it travels a distance AB in 6 seconds, which means AB is equal to 6v. Suppose the car takes t seconds to travel from point B to P, then BP is equal to Vt. Therefore, AP is equal to AB plus BP, which is equal to 6v plus Vt. In triangle AQP, we know tan 30 degrees is equal to PQ by AP. Substituting the known values and simplifying, we get square root 3 times h is equal to 6v plus Vt. Consider this as equation 1. Similarly, in triangle BPQ, we have tan 60 degrees is equal to PQ by BP. Substituting the known values and simplifying, we get h is equal to root 3 times Vt. Consider this as equation 2. Now, substituting equation 2 in equation 1 and solving for t, we get t is equal to 3 seconds. So, the car will take 3 seconds to reach the tower. So, using the angle of depression, we found that the car will take 3 seconds to reach the tower.